Alibaba just dropped an open weight model that matches GPT 5.2, Claude 4.5 Opus, and Gemini 3 Pro on most benchmarks. 397 billion parameters, Apache 2.0 license. You can download it right now. It's called Qwen 3.5, and the architecture behind it is worth understanding because it tells you where this whole field is heading. Quick context. Open weight means you get the full model weights. You can run it on your own hardware, inspect it, fine-tune it. It's not open source in the strict sense. The training data and code aren't released, but the model itself is yours. Now, Qwen 3.5 has 397 billion total parameters, but only 17 billion are active for any given token. It's a sparse mixture of experts model. It stores the knowledge of a massive network, but runs at the cost of a much smaller one. The model has 512 expert subnetworks. For each token, a router picks the best 10, plus one shared expert that always runs. 11 experts active out of 512. This idea isn't new. Mixtral, DeepSeek, and the Switch Transformer all explored sparse MoE before Qwen. What's new is the scale and what they combined it with. Walk through it step by step. A token arrives. The router, which is just a small linear layer, produces a score for each of the 512 experts. It picks the top 10 scores. Those 10 experts process the token in parallel, and their outputs get weighted by the router scores and combined. The shared expert adds its output on top, every time, regardless of routing. Why does this matter? A dense model with 397 billion parameters would need to run every parameter for every token. That's expensive. With sparse MoE, you get the same storage capacity, the same breadth of knowledge across those experts. But you only pay for 17 billion parameters of compute per token. Different experts learn different things during training. Some might specialize in math, others in code, others in specific languages. The router learns which experts are useful for which inputs. MoE handles the feed-forward layers. The attention side is where Qwen 3.5 diverges from a standard transformer. The model has 60 layers, organized into 15 repeating blocks. Each block has 4 layers. 3 use gated delta-net, a form of linear attention, and 1 uses standard grouped query attention. So 75% of the model runs linear attention, and 25% runs full quadratic attention. The reasoning behind the 3-to-1 split: most processing doesn't need full attention. Linear attention handles the bulk of the work cheaply. The expensive quadratic attention layers are reserved for the hard parts, tasks that require precise recall over long distances. Gated delta-net wasn't invented by Qwen. It comes from Songlin Yang and collaborators at NVIDIA, published at ICLR 2025. Qwen first tested this hybrid layout in Qwen 3 Next, an 80 billion parameter model released in September 2025. That worked well enough that they scaled it up to 397 billion parameters for Qwen 3.5. The full attention layers use grouped query attention with 32 query heads sharing just 2 key value heads, a 16-to-1 ratio. That's aggressive compression, but it saves memory without losing much quality. Standard self-attention has every token look at every other token in the context. If you have n tokens, that's n times n comparisons, an n-squared operation. Double the context length, you quadruple the compute. At 256,000 tokens, that becomes a serious bottleneck. Gated delta-net sidesteps this. Instead of every token attending to every other token, it compresses the history into a fixed-size state, like a running summary. New tokens update that summary and read from it. The cost is linear, O of n. The result: 8 to 19 times faster inference depending on context length, compared to Qwen's previous architecture. That's how you get a 256,000 native context window, extensible to 1 million tokens with rope scaling, without the compute bill exploding. Most multimodal models bolt vision on as an afterthought. Train a language model, then attach an image encoder and fine-tune. Qwen 3.5 does early fusion. Image and video tokens get injected at layer 1, right alongside text tokens, from the start of pre-training. The model learns to process vision and language together, not separately. Each image gets broken into patches and encoded into 576 tokens per 512 by 512 region. Those visual tokens go through the same 60 layers as text. Same attention, same MoE routing, same experts. The model supports 201 languages, has a vocabulary of over 248,000 tokens, and can interact with desktop and mobile interfaces as a visual agent. That last part is still early, but the architecture supports it natively. The benchmark numbers are strong. MMLU Pro, 87.8. That's a broad knowledge test. Live Code Bench version 6, 83.6, real coding tasks. MI 2026, 91.3, competition level math. Math Vista, 90.3, visual math reasoning. Qwen claims it outperforms GPT-5.2, Claude 4.5 Opus, and Gemini 3 Pro on 80% of evaluated categories. These are across text, code, math, and vision tasks. A couple of caveats. These are self-reported numbers. Alibaba ran these benchmarks themselves. Independent verification is still ongoing, and benchmarks don't capture everything. Real-world performance on your specific task can differ significantly. Still, the numbers put Qwen 3.5 in the same tier as the best closed models, and it runs at 60% lower cost and 8 times the throughput compared to the previous Qwen 3. 2 years ago, open-weight models were clearly behind the frontier. GPT-4 came out and nothing open came close for over a year. Then Llama, Mixtral, DeepSeek, and now Qwen started closing the gap. Qwen 3.5 is the first open-weight model that credibly matches the top closed models across a broad set of tasks. That gap keeps closing. The cost of frontier intelligence is collapsing. Qwen's API charges around 12 cents per million input tokens on Alibaba's domestic cloud. That's an order of magnitude cheaper than the equivalent closed models. And because it's Apache 2.0, anyone can fine-tune it, deploy it on their own hardware, build products on top of it without depending on someone else's API staying online. A startup can take this model, specialize it for their domain, and run it themselves. That wasn't possible at this quality level a year ago. This also shifts the geopolitical picture. China's AI labs, Qwen, DeepSeek, and others, are matching U.S. labs on benchmark after benchmark, despite export controls on advanced chips. The pattern keeps repeating. Open source lags behind the frontier, then catches up. Then the frontier has to keep pushing forward. Qwen 3.5 is the latest proof that this cycle isn't slowing down. Qwen 3.5 isn't doing anything architecturally new. Sparse MoE, linear attention, early fusion, all of these existed before. What Qwen did is combine them well, scale them to 397 billion parameters, and release it all under an open license. The result is an open-weight model that competes with the best closed models in the world. 6 months from now, there'll be another model that pushes further. But right now, Qwen 3.5 shows that frontier-level AI doesn't have to be locked behind an API. The techniques aren't new. Open access at this performance level is.